Hi everyone and welcome back to the channel. Today I can't wait to show you our latest AI Accelerator. Hot off the press, this accelerator was imagined by our very own CTO and Chief Architect Carlos Iturria. The Attrition Agent at the center of this accelerator has been custom trained and is extremely accurate at identifying those customers in your organization that are highly likely to churn as part of customer attrition. Now, we all know that finding new customers is hard, and building that trusted relationship takes time and a lot of effort. We also know that we want to do the right thing by our customers, but sometimes we just don't know what the issues are or which customers actually have concerns. The Synapsewerx Attrition Agent can be easily trained on your specific customer data. It will identify trends and issues, and then as part of a wider solution, it can proactively identify those customers at higher risk before alerting you to the potential problem. This then gives you the opportunity to proactively resolve any potential issues and restore trust instead of losing a valuable relationship. Today, the Synapsewerx engineers behind the solution are going to provide you with a detailed walkthrough of the solution architecture. They will show you how the AI agent can be implemented within an enterprise application landscape and give you a demonstration of the secure containerized AI agent at the core of this accelerator. Now, get ready to hear from the Synapsewerx team who are going to take you on a journey through the solution. Enjoy.
Let's take a moment to introduce the Synapsewerx Boomi Accelerator for attrition prediction. At its core, this AI-powered engine helps identify when key individuals, such as customers, employees, students, or associates, are at risk of disengaging. By analyzing behavioral and transactional patterns, it surfaces early warning signs well before traditional reporting. This enables timely, targeted interventions that not only strengthen relationships and reduce attrition, but also lay the foundation for long-term business success. For individuals, it means feeling recognized and valued, often restoring trust and strengthening loyalty. Here's a high-level look at the conceptual design behind our intelligent attrition prediction engine. On the left, you will see a range of enterprise systems for which we source user-related data. These can include platforms such as Salesforce, ServiceNow, Oracle, SAP, or any industry-specific application, capturing signals such as employee performance, student engagement, customer activity, etc. All of this data flows into the central DataHub, where it is unified into structured golden records. These golden records bring together rich multi-dimensional attributes, such as preferences, service tier, consumption patterns, complaints, engagement metrics, that gives us a holistic view of each individual. Next, this consolidated data is passed through our attrition prediction, a custom machine learning model that has been pre-trained to assess attrition risk at high levels of accuracy. It outputs a dynamic attrition score for each individual, continuously updated as new data comes in. These scores update the golden records in near real time, enabling continuous prediction. This means that we can react to subtle behavioral shifts and surface early warning signs as they happen. Once a high-risk score is detected, actions can be triggered across integrated third-party systems. For example, an escalation could be created in a case ticket to ServiceNow or a notification in Salesforce. But it doesn't stop here. Because we maintain an always up-to-date golden record layer, this data becomes incredibly powerful. And when accessible via conversational interfaces, such as custom chatbots, this allows teams to interrogate risk profiles in a more human-centric way. And finally, the Boomi Control Tower provides the operational governance to manage these AI-driven workflows, offering visibility, auditability, and governance across your AI agents. What makes this architecture truly valuable is its versatility. Whether in higher education, workforce management, or customer retention, it adapts seamlessly to your specific use case, turning signals for your ecosystems into timely data-driven interventions. Let's explore a specific use case. For this, let's demonstrate how this engine is easily applied to a customer attrition prediction scenario. As mentioned, it starts with a continuous ingestion of evolving customer data into Boomi DataHub, where it builds always up-to-date golden records. From here, we access these records in near real time to identify key variables that are highly correlated with attrition. That curated data is then sent to a pre-trained machine learning model, which delivers accurate attrition scores for each customer. When a score crosses a defined threshold, the engine automatically triggers an action, in this case, creating a ticket in Jira for a customer success team to follow up. Meanwhile, those golden records can also feed into an intelligent chatbot interface for deeper interrogation and insights. An important observation is that this solution leverages proprietary data sets used to train a small model, yet highly accurate ML prediction model that can be customized for any industry, vertical, organization attrition challenge. For example, our attrition prediction engine is highly adaptable across industries such as in retail and financial services. It could help predict customer attrition so businesses can act early with personalized offers and strengthen loyalty in competitive markets. In higher education, universities can detect early signs of student disengagement, enabling timely academic support to boost retention and performance. For human resources, it identifies behavioral signals of potential employee turnover, helping organizations retain talent and reduce recruitment costs. And in healthcare and insurance, for example, it could support members' retention by flagging those at high levels of risk, triggering tailored well-being programs, or plan adjustments to improve satisfaction. The common thread here is that regardless of the industry, the key is using data to surface early signals, so actions can be taken before attrition becomes a problem. In order to demonstrate this accelerator, let's analyze the solution architecture for this customer attrition use case. As we said, we firmly believe that any meaningful exploration of AI must begin with high-quality, up-to-date data that support near real-time business operations. To achieve this, organizations need a robust mechanism that can automatically synchronize, deduplicate, and enrich golden records across all backend systems. This is where Boomi plays a pivotal role by extending traditional integration capabilities through its always current DataHub. Boomi ensures that data remains accurate, consistent, and ready for intelligent, real-time decision-making. As shown in this diagram, Boomi DataHub sits as the heart of our AI agent reference architecture. It acts as the foundation for seamless data integration and reliable AI-driven actions. In the bottom right corner, we see how the attrition prediction ML model connects into this architecture. This model, custom trained for high predictive accuracy, monitors behavioral signals and instantly updates attrition scores as changes are detected in the golden records. With this architecture, we unlock a near real-time capability to identify customers who are highly likely to attrit. And critically, we can trigger automated case management, raising tickets and initiating proactive engagements before it's too late to act. Let's dive deeper into this architecture and going step by step on how Boomi creates this end-to-end AI action pipeline. It starts at step 1, where customer data flows in from enterprise systems like Salesforce in this case into the Boomi DataHub, where we maintain unified golden records across users, products, services, interests, cases, loyalty programs, etc. At step 2, curated customer data is sent to this pre-trained ML model at runtime. This model evaluates behavioral signals and returns an attrition score in real time. Next, in step 3, that score is written back into the golden record, updating the customer's profile with near real-time risk insights. If a score crosses a predefined threshold, step 4 triggers an escalation that is handled by another intelligent AI agent, provided with tools and instructions on how to handle escalations. For example, in this case, if a threshold is larger than a particular threshold, a ticket will be created in Jira to alert a customer success team to proactively recommend the next actions. Step 5 enables that enriched data to be accessed through a Boomi AI chatbot, allowing users to interrogate attrition insights conversationally. And finally, in step 6, the Boomi Control Tower provides full oversight, governing and monitoring AI agents across channels and ensuring everything runs reliably and at scale. All of this is underpinned by a scalable ML model deployment containerized at runtime escalations, enabling fast and accurate decisions across a wide range of scenarios.
So I'm quickly going to walk you through the Boomi processes, which we divided into two parts. The first process, what it does is take the data from the Salesforce, which is user activity data, and then move the data to the DataHub, Boomi DataHub. The Salesforce user activity data, we have created a custom object in Salesforce to record the user activity data. So it basically records the basic information of the users, its logging details, what time they last login, was the login done with the web portal or mobile, plan start date, plan types. So it records basic elementary details of the user activity which get recorded. And then the same data, once it's being recorded in the Salesforce, but when we initiate this process, will be taken out and would be moved to the Data Hub. And we have created a Data Hub model here. So if you see, there are already some records up here, but I'll quickly walk you through the model. So this is our Data Hub model, which we have created to get the data from the Salesforce, which basically is user activity data. So we have created a platform user model. We have provided some match and merge rules, the match on user ID, which comes from the Salesforce, and we have some basic data quality stuff being configured. So the data should have the email ID mentioned, and then first name should be proper. The plan type should be one of these. Because that's a condition that we have put. Anything apart from that is not acceptable. We'll go to the quarantine. And then we have activity type. So we have a predefined activity type which should be mentioned in the which should be inside the Salesforce data. It is done just to put up a quality check in process so that none of those rubbish data or garbage data should come to the master data to the data hub or data management system. So we have put we have put these steps of qualities checks, and now showing you the data how it looks, right? So this is how the data is going to reflect into this. I'm anyhow going to run a few sample tests from the new records. I'm not going to use these records anymore, but this is how it is going to reflect when this comes to the to this particular data model, and then these are the golden records. And then anything which fails the quality checks will go into the quarantine. So you would have you can see it here. There are some data quality errors which has been recorded. So it's just because they have not met that step that I've shown you earlier, and that is the reason it has gone to this data quality error. For this particular recording, our focus is not to cover this MD master data management system in detail, but this is the quite elementary thing that I want to show you before we move to the next step of moving the data from Salesforce to the Data Hub. So that's the first step in the process of moving the data or extracting the data from Salesforce and putting in the Data Hub. But then second is step in the process, once data has been transported to the Data Hub and then golden records has been created in the Data Hub for right set of data, is to take each of those records. So I'll rather represent it with a flow diagram in here. Okay, so for each of this record, we extract the data back from the Data Hub, and then we go and make a call to API which is being constructed, which is being hosted on the Kubernetes, and we make a call to this API to get the prediction score. As Carlos has talked earlier, he has created a model which is exposed as an API. So we are making a call to that API through here to get a prediction score. If the prediction score is more than 0.9, it comes more than 0.9, then we go further. So we get a prediction score from here, and then we check if the prediction score crosses the threshold more than 0.9. That's when we think the user have the probability to move out. So what we do is we go and create a ticket into the Jira. But if it is less than 0.9, we'll just update the prediction score back to the DataHub and back to the DataHub. So just to clarify this thing in a more better way, what I'm going to go show the flow diagram for this particular process, right? I would like you to walk you through this one. So what happens is we query the data from the DataHub. We do the basic mapping, and then we make a call to the prediction API, which is, again, as I said earlier, is the API, is the model built to provide the prediction and expose an HTTPS. So we make a call to that. It runs on Kubernetes, and then if output which comes out of it, if it has a attrition score more than 0.9, what we do is we go and create a Jira ticket for it. But before creating a Jira ticket, we first check that if there was already a Jira ticket existing for this particular user record. If there is already existing Jira ticket, we don't create it. We simply update the DataHub with the new iteration score. And if it is not created, then only we go and make a call to the Jira ticket for the Jira ticket creation. And this call we do using the Boomi AI component. I'll walk you through that component too. And once the AI component, Boomi AI agent is being invoked, then the output of the agent would be provided, which pretty much talks about if that Jira ticket has been created properly or not. And if the Jira ticket has been created properly, the output is recorded with the link of the Jira ticket and updated back into the DataHub. So just to show you how we are interacting with the agent, you see it here. We have introduced this agent. Boomi has introduced the agent step, which basically allows you to interact with the agent, which is hosted on the agent control tower. So here, if you see, we have configured the ticket master agent, which basically, okay, let me show you that agent here in Boomi. So we have an agent deployed, which is Ticketmaster. So we are accessing this Ticketmaster agent here, which basically facilitates the creating the Jira ticket into the Boomi. And while doing so, we have to provide the prompt to create the Jira ticket. So we have here, if you see, we have provided that static prompt with some dynamic values into it. Which pretty much reflects the unique user informations and then reason for the ticket creation. So we have provided the prompt. So what we are doing is through Boomi, we are invoking the agent, which is hosted on the control tower, created in the agent garden, and then providing them the prompt. And the message in the prompt is coming from the data extract that we have taken out from the DataHub. So it's creating this message based on the value being passed, and these values are coming out of the DataHub. And once being passed, it will go and create the Jira ticket. And then the interaction between the agent and the Jira is being pretty much configured into the agent. So what that agent is doing, if you see this agent, Ticketmaster agent, it's making a call to, there are two functions to it. So first thing is create a Jira ticket and check for the existing Jira ticket. So right now we pretty much calling this create a Jira ticket from the Boomi process. And then if you see the task which has been linked in here for creating the Jira ticket, it's linked to a tool set. The tool set name is Jira ticket creation tool. So if you go inside this tool, we'll see the configurations of this particular tool set. What it is doing is making a call to the Jira API to create the ticket, and then we are passing the key, which is nothing but a project name, the issue type, which is for now it has support for us, and then summary, the detail of the ticket, and in the runtime. And all this value that you are seeing is going to come from the Boomi, and that's what is coming from the Boomi. If you see all those value that we are passing, so we are passing from here, it's making a call to the agent, and agent is invoking the tool set, and tools, these are the dynamic parameter of the tool set that we need to pass to execute the tool set. So these all values are coming from the Boomi integration. So now going back to the Boomi integration. So when we pass this information, the Jira ticket is being created and the DataHub is being updated. So now what I'm going to do, redeploy this tool set. So now what I'm going to do is I'll go to the agent garden. I've created another agent which basically invokes Boomi. So I'll show you this agent too. So there are two processes that I've shown you. One is to load the data and other one is to um, uh, invoke the prediction model. So here what I've done is basically the process one. There are two tasks. There are multiple tasks being configured. So I'll walk you through each of those tasks. So the first task is basically sync user activity data. What this task is doing is invoking the Boomi process, which is load data from Salesforce, load data from Salesforce to the DataHub. So it's invoking that Boomi process. So when I'm going to invoke, it's going to take the data from the Salesforce and load it in the Boomi DataHub. We are going to see the outcome of it once we execute this one. And the other one is basically run prediction. So what this run prediction does is invoke the other Boomi process that I've shown you earlier. And when it invokes that run prediction process, and then that run prediction process basically internally invokes the ML model, and then decides if it needs to create a Jira ticket or not. And once all those things is done, it goes back to DataHub and update the prediction score along with the Jira ticket if it is created. So now, so before, in order to run this, what I'm going to do is create a fresh, let me deploy all of these. So what I'm going to do now is to use cloud to generate a sample data. So for the sample data, I've provided Carlos and Milk information in here, and so and then some detailed information about last logins, right? So that we can have a right prediction generated. So cool. It has generated a sample data. So let me create a file for it. Okay. And now I'm going to use Salesforce data loader to load this data to the Salesforce data object. Okay. So now you're seeing like there were two records which were generated, one for Carlos, another one for Malcolm, and that has been loaded successfully to the Salesforce from the data loader. And now I'm going to jump back to the agent garden, get the conversational agent started, and we'll ask to load the information from Salesforce to the DataHub. So I've provided some conversation started already here. So user activity information syncing is needed. Please initiate the sync, right? So I'm just going to click on it. So if you see, what it has done is it has taken the full extract of the Salesforce data. So there were total 34 records, which basically includes the 2 records we recently updated for Carlos and Milk, and it has loaded into the Boomi DataHub. And then what I'm going to show you is the record for Carlos and Milk reflecting into the DataHub. So let's see. And here you see the Carlos record has been uploaded to the DataHub, and then where is Milk record gone? Here is the Malcolm record. So these 2 records were the new record that we created. So what it did is took a full extract of the previous records and loaded it here. The reason why you see the difference in the number is because it's pretty much taking the full extract record. Few of the record we have marked as ended, so it has taken that record also out. But because it is marked as ended, it's not showing into the active records. So we are just focusing on active records here. So in total, there are total 34 records, but then we have these many active records, and which pretty much includes Carlos and Malcolm data, which were the new user informations which we just uploaded. Now we have the information been uploaded, but then if you notice, there is no attrition probability provided for the new user. So what we are going to do is to run this from here again. So I'm going to ask it to run prediction, and it's going to run the other Boomi process. Once this process is successfully executed, then we'll start seeing the attrition probability, and if any Jira ticket is raised, then we'll see the ticket linked also here. Okay, so although the agent is still collecting the response, I do see agent has invoked the process, and then predictions are being listed for Milk and Carlos. So the Carlos prediction came out to be now 0.93, and I think for Milk also the prediction came out to be same, because the parameter was pretty much the same for them. So where's data? Malcolm. The prediction was 0.93. So that Jira ticket has been generated for both of these issues, and probably by now we would have the response. Yes. So if you see, we got the response back, and it does says, okay, the ticket has been generated, and predictions has been updated, right? So if now you see the prediction score, attrition score for both the new records and then respective Jira tickets, and I'll go and show you here. So previously there were only 2 Jira tickets created. Now there should be 2 more for, yeah. So now we have 2 more Jira tickets. So UAP 11043 is Carlos, and 0042 is Milk. We will be able to relate through here with their ID. So with 42 is Carlos and 43 was Malcolm. So the ticket has been generated for both the user IDs here, and with the information about why they have, with the information about their attrition predictability, and if you see, the details also have been provided. So it just says has not logged in from the app for this long days, and then the attrition score is high, and that's the reason they're generating the ticket, this particular ticket. So that's one part of it, and pretty much because the record is we got a lot of golden records in the DataHub, we can pretty much use. I've created another function, right, which basically allows this agents to query anything from the DataHub. So if I want to use this agent, let's say, to query all the user which has attrition rate more than 0.5, give me the details. So what I'm going to do is I've already prepared the query. So I'm just going to ask this agent to query all the users which have a high attrition rate more than 0.5. So it's going to give me the details of it. Okay. So if you see it here, it's just giving you the response back. Yep. So if you see this, it has given you the detailed response back of users who have more than 0.5 attrition rate, and with the detailed information. So that's pretty much here. And anything related to, so I think in the last video we talked about the agent control tower. So I'll take you to the agent control tower and then show you the metrics up there. So if I select my agent, it's going to show me all the metrics related to these agents which are being invoking, right? So the total token, the latency of these agents, right? So all of these has been recorded in here, which you'll be able to see. Yeah. So now what I'm going to do, so far now we were interacting using the AI agent, right? Now what I'm going to do, just to give a glance of the Boomi process, how it's functioning, right? And then show you how the data looks like when you are querying each of these steps, and especially how the data looks when you are querying, when making a call to the Boomi AI agent from Boomi integrations. So what I'm going to do, I'm going to generate another sample data. Okay, so it has generated a sample record for me. Let me upload this record. So I'm going to upload this record, and we'll manually run the process to show you the process execution. Okay, CSV file has been loaded. Okay. Okay, so it does say like it has successfully loaded one record. Okay. So what I'm going to do, I'm going to run both of these processes individually. Previously, I was running it to the agent. So I'm manually going to run this process and show you how the data is getting loaded and how the prediction is being calculated and Jira ticket is being created. So, okay. So here you are going to see it has taken out like how many? Near about 35 records from the Salesforce, and it's like a full merge. So it has uploaded all the 35 records to the DataHub, which includes my data too. So we can see it here. So now you see a record has been created for me and updated here in DataHub. So there's a record entry for me now. And now what I'm going to do is to run the other process, which basically run the prediction calculation, and then if needed, it creates a Jira ticket and then updated Boomi DataHub back with the attrition score. So let me do it. Yeah, so it has executed it. It might be taking some time in Jira ticket creation. Okay, so cool. So now what has happened, right? It has taken out all the records from Boomi DataHub. So I think it has gone. Yeah, so it has gone and taken out all the records from the Boomi DataHub, and for the record which has come out of the Boomi DataHub, right? I think there should be many, but there are a lot of record, like 10 to 12 record which has come out of the Boomi DataHub. And then once these records has been returned from the data hub, it has make a call to the AI prediction services. And once this service has been invoked, it give you the prediction response for each of these records. So if you see, it's going to give you the response for each of this record, like what is the prediction score for these records. So it is 0.68 for the first record, and then there are other attrition records, 0.31 for another record, right? So it gives you the prediction score for each of the records. Then there's a check which happens. So if the record has attrition score more than 0.9, then only it goes further. But then once it yeah, if the record has there is a check which happens. So if the record has attrition rate more than 0.9, then it goes further. But then we have another check, right? So because we are doing the full syncing. So if the record has a Jira ticket created already in the past, we don't create a duplicate Jira ticket for it. So we do check it if there is a ticket linked. So whenever the ticket is created, right, there is a link being provided up here. So if this value has been populated, that pretty much shows that the ticket has been already been created. So if that we have a value in that particular for that particular column, we don't create the duplicate ticket. If there's no value in that, that means there is no earlier ticket being created. Then only we go and create the ticket for that particular record entry. So here there was one record which was like new record which I entered, for which the ticket was not being created and iteration score was high. So you will see it here for that particular record. What it is doing is to create the Jira ticket. So if you see the payload here, it will say, okay, so this is the command which is getting passed to, or prompt which is getting passed to the AI agent. So we are telling AI agent that this particular user has not logged in last these many days, and then we need to create a Jira ticket because the iteration score is high, comparatively high. And this is these all parameter that you are seeing, right, was passed as a parameter values. So it's going as an on the runtime to the AI agent, and AI agent internally invoking this tool set. And then I showed you earlier in the tool set, there was a parameter being provided in the payload. So that's what we are passing from here. And once this ticket has been created, what we do is take the ticket ID and take the iteration score and then update it back to the data hub. So yeah, just like that, right? So we take the ticket, if ticket has been there, so we take that ticket ID and take the iteration score and update it back to the data hub. So you will see, because the record, the prediction score for my record has been created. So you'll see now in the data hub, there would be an entry of the iteration probability and then ticket which has been created. And if I go back here, there would be a ticket generated, a new ticket generated. Yeah, so you see this, there is a new ticket generated for the new entry which I just made. Yeah. So yeah, so that's pretty much it. So for the demo that we have seen, right, it's pretty much covering everything in here. So we made a call to the DataHub query, and then we have done the prediction invocation, which invokes an internal LLM model to give the prediction score. And then, yeah, if it needed, it use Boomi AI agent to interact with the Jira and create a Jira ticket, and then update the DataHub in the last, right? So this was the whole demo in the nutshell all about.
Welcome back. You've just seen how the Synapsewerx Attrition Agent leverages Boomi to identify those customers at potential risk of attrition and raise a ticket for a real-world human agent to proactively review the customer's account and reach out to them to resolve potential concerns. The Synapsewerx Attrition Agent is well suited to a range of industries, including telco, retail, energy, utilities, education, transportation, services, and a host of others too. Once trained on your data, this agent can work in near real time, helping you retain your loyal customer base. Now, we hope you've enjoyed this walkthrough of our Attrition Agent Accelerator. If you want to know more, or if you want to organize a personal demonstration, then please reach out to me or the team using the details in the description below. Thank you.